Hello students, today I am here to teach you chapter 6 in your textbook that's called area. So in future purposes, we can use capital A instead of area, otherwise you have to write down the word again and again. What is an area? Area is a mathematical term defined as the two-dimensional space taken by an object. Where we use area in real life? So in farming, farmers need to know the plot area where they are growing their seeds or vegetables. In building, how much carpet or tile area that you need to cover the room. Or when you want to paint the walls, how much paint you need to cover up all the walls. So without knowing, we use area every day. So here, when you take any space, closed figure, so area is defined as this part. So we use capital A for area. And what's the unit we are using for area? We can use millimeter squared or square millimeters, square centimeters, square meters, square kilometers. Sometimes we use hectares, acres. Those are imperial units. But you need to know these units to convert and find out the area. So what is 1 square millimeter means? So when you take 1 millimeter length and another 1 millimeter length square, the area is called 1 square millimeter. If you take 1 centimeter length with another 1 centimeter length square, we call this one is 1 square centimeter area. So when you take 1 meter length and 1 meter length square, we call it 1 square meter. So you need to know proper units in area. So sometimes you get different units, so you need to know the conversion. So normal conversion is millimeter to centimeter, 10 millimeters to 1 centimeter, 100 centimeters to 1 meter. Now we'll look at what are the shapes in your syllabus that we need to find out the area. So the first shape is rectangle. So this board is also a rectangular shape. So it's important to learn about rectangles. So we'll take a rectangle. So here opposite sides are equal. So I can take this as length. What about this side? We call it breadth. I'll write length for the longer side and breadth for the shorter side. And opposite sides are equal. So how can we find out the area? So we need to find out the space taken by this object, the rectangle. So here you know what's the area of a rectangle from the previous classes. You know that's equal to length into breadth. So here we can write the area taken by a rectangle is length into breadth. So you need to memorize this formula to do the area in a rectangle. We'll take some examples. Example, if this is 10 centimeters and 3 centimeters. What it means? We can divide, we know what is 1 square centimeter means? 1 centimeter, 1 centimeter square. So if we can divide 1 centimeter squares, how many squares you can draw here? There are 10 squares this way. This way 10 squares. What about this way? How many squares we can draw? There are 3 1 square centimeter squares are there. So all together how many squares? 30. 10 and 3. So that's why we can see the area of a rectangle is 10 times 3, that's 30. So here again we can explain using this example. It works for the area of a rectangle. So what's the area here? 10 squares here, 3 squares all together, 10 times 3. So you get 30 square centimeters. We'll take another one. So this one I can give 7 centimeters, and if it's 2 centimeters something. So what's the area of this rectangle? Take the length, multiply by the breadth. So we can write A equals 7 times 2. You get 14 square centimeters. So remember this formula if you want to find out the area of a rectangle, length times breadth. Now we'll look at the next shape. That's a square. So what is a square? Square is a quadrilateral with all sides are equal. So here if we take L as one length, this is also L. So according to the definition, what's the area of a square? We can straight away use A equals L times L or L squared. So I can highlight this. So if you know one side, just multiply the value by itself. We'll take an example. We'll take a square with one side is equal to 3 centimeters. You know the length for this square is 3 centimeters. So what's the area? Area is 3 times 3 or 3 squared. You can write 3 squared or 3 times 3. So what is 3 times 3? 9. What's the unit here? Square centimeters. Now we'll look at the third shape that we need to find out the area. Parallelogram. So what is a parallelogram? Before that we'll take a rectangle. We'll take a rectangle. With length L and breadth B. So I'm now taking a triangle like this. And I want to cut this triangle and move it to the other side. Now, without that, what's the area of the rectangle? We know area of the rectangle is L into B, length into breadth. Now, what I'm doing, I'm cutting this triangle and moving to this side. So, I'm getting this shape, this part here. Now I want to remove this part. What's the shape I'm getting now? I am getting a parallelogram. So here I move this part here. So what's a parallelogram means? Opposite sides are equal and parallel. So this side is parallel to this one and this side parallel to this one. So here what I did, I just moved this triangle, but the area, the space taken by this object is the same. So what's the area of the parallelogram? You get the same formula. So here, what's the area here? L. L is the length of one side, and what is this one now? This one is B. B is the perpendicular height of the parallelogram. Earlier B was the breadth of the rectangle, but in this case, if it's a parallelogram, one side and the perpendicular height you get. So here I'll use a different notation now. If this part is H, I'll write down here. If the length of the parallelogram is L and the perpendicular height of the parallelogram is H, what's the area of the parallelogram? L times H. So you can memorize this formula. So for example, if I give you a parallelogram, parallelogram means opposite sides are parallel. So you need to give something like this for a parallelogram. So I'll give this side is 10 centimeters, and here perpendicular height is 3 centimeters. So what's the area of this parallelogram? A is equal to 10 times 3. So what is 10 times 3? 30 square centimeters. I'll give you another one. This side, a parallelogram this way. And it's mentioned these two are parallel and these two are parallel. So one side is 8 centimeters and the perpendicular height is 2 centimeters. So what's the area of this parallelogram? So area is equal to 8 times 2, that's 16 square centimeters. So what are the shapes we discussed now? A square, a rectangle and a parallelogram. Now we'll look at the next shape. So here this is about triangles. So you know already there are different types of triangles. So first we'll look at a right angle triangle. So what is a right angle triangle? Means one angle is 90 degrees. So first we'll take a rectangle. So rectangle with length L and breadth B. Now I want to divide this into two equal triangles. If this is a rectangle, what's the area? Area of a rectangle is length into breadth. But if I divide this into two equal triangles, so what is the area of one triangle? You get half of it. So here, what happens here? You take half times L times B, because these two triangles are equal. So what's the formula you are getting? If you know length of one side and the perpendicular height, because in this one, this is a right angle triangle. If you know the length and the perpendicular height, you can multiply these two and divide by 2, or half times L times B. So if, I'll take different letters now. If there's a right angle triangle with base L and the height H, we'll take base A here. If the base is A, so what's the area of this right angle triangle? A is equal to half times the length of one side or base into perpendicular height. So you can use this formula when you get a right angle triangle. For example, we'll take different sides. you are getting a right angle triangle. One side is 7 centimeters and the other side is 4 centimeters. So this is the height, perpendicular height. So what's the area? Area of this triangle is half times base length is 7 and height is 4. So basically when you simplify, you get 7 times 4 divided by 2, 2 times 2, 7 times 2, you get 14 square centimeters. So when you get a right angle triangle, how we find out the area? We need to know the base length and the perpendicular height, multiply it together and divide by 2. Now we'll look at the second type of triangle, acute angle triangle. So acute means one angle is acute. So I can just draw a triangle like this. So here what I'm trying to do, so if you know this length is A and the perpendicular height is h, perpendicular height is h, how can we find out the total area of this triangle? So I'll take each side different letters. So here I'll take this length is x, this length is y. So here we know the total length is A. So what is A? In terms of x and y, we can write A is x plus y. And also, what is this shape? When you take this triangle, it's a right angle triangle. So we already did how to find out the area of the right angle triangle. So you take base into perpendicular height into half. So we can find out the area of this part. Area is half times x times h. So what's the area of this part? The other triangle. Half times y times h. Now, if I want the area of this whole triangle, I need to add these two together. So what I'm trying to do, I'm adding these two areas together to get the total area. So I'll do the half x h plus half y h. Now I can see half h is common. I can take it out. So what happens when I take half h out? I get x plus y. So what is x plus y? We know that x plus y is a. So what's the formula we can find out the area of an acute angle triangle? Half times h times a, or I can rewrite this as half times length of the base, that's a, times the perpendicular height. So when you get any acute angle triangle, you need the base length and the perpendicular height. So I'll take an example. 8 centimeters given this side and the perpendicular height is given 3 centimeters. So how can you apply the formula? You can straight away write area is half times the base length times the perpendicular height. So how can I simplify this? First multiply the numerator, 8 times 3 and divide by 2. So you can simplify 2 times 4, 4 times 3, you get 12 square centimeters. Now we'll look at the third type of triangle. So what is the third type of triangle? Obtuse angle triangle. So obtuse means angle more than 90 degrees and less than 180. So we'll try to draw an obtuse angle triangle, something like this. So this is the obtuse angle. Now here what we can do, we need to know this length. We'll take this one as A, and I want to extend this line and draw a perpendicular to that. I'll draw a perpendicular, and I'll take perpendicular height is H, and I'll take this part is X. Now I want to find out the area of this triangle. So how can I find this area? I can take the full triangle and subtract the smaller triangle to get this obtuse area of the obtuse angle triangle. So here we know this is a right angle triangle, the big one. So straight away I can write the area required is equal to half times. So when you take the big triangle, what's the base length? X plus A. So I can write A plus X or X plus A, and the perpendicular height is H. And I need to subtract the area of the smaller one. So what's the area of the smaller one? Half times the length. Base length is now X. So what's the perpendicular height? Perpendicular height is H. Now I'll simplify. First I'll open brackets and simplify. When I multiply this by A, so I need to multiply both these two by H. So I get half A times H plus half X times H, and subtract half times X times H. What can I see? I can see these two terms get cancelled out. So what is remaining? You get half times A times H. So what is A? A is the base length of the obtuse angle triangle. And what is H? A perpendicular drawn to that triangle. Normally, in an obtuse angle triangle, the perpendicular we need to draw outside the triangle. So here, if you know any triangle with base length A and the perpendicular height is H, you can easily find out the area of a triangle using half times A times H. For example, I'll take something like this, a triangle like this, and you have given this is 8 centimeters, and the perpendicular height normally we can draw outside. This is 3 centimeters given. What's the area of this triangle? We just need the base length and the perpendicular height. So A is equal to half times the base length 8 and the perpendicular height is 3. So when you simplify, you get 8 times 3, 24, divide by 2, you get 12 square centimeters. So basically, in any triangle, if you know the base length and the perpendicular height, you just multiply and divide by 2. Now we'll look at another shape. So what is a trapezium means? Trapezium is also a quadrilateral, four-sided shape, but what's the special property in trapezium? We know one pair of sides is parallel to each other. So if you take this side and this side, we know that these two sides are parallel. And now we'll try to find out the area of this trapezium. So for that, I'll take this length is A and this length is B. So what I can do, I am taking the same trapezium and draw it here upside down. So I'm taking this one turn other way around and draw here. So here this length comes here then. So you get B length here. So this part you get here. And then what happens? This one comes to this side. So here you get something like this. So same trapezium, I drew it here upside down. So this length becomes this one, this length becomes this one. So what you get here, when you take two trapeziums, you get a parallelogram. So what's the big parallelogram base length? This is the base length. Now I'll take any height, perpendicular height as h. So how can I find out the total area of parallelogram? Total area of this parallelogram. I know in a parallelogram you need base length and the perpendicular height. Base length is a plus b into h. So now we know we get same trapeziums, two trapeziums. So if I want one area, what can I do? I can divide this by 2 because you get same equal trapeziums here. So if I want the area of trapezium, what I can do? I can take this area of the parallelogram, divide by 2. So what's the formula I am getting now? I am getting a formula for area of trapezium. What is A here? A is the length of one parallel side and B is the other length of other parallel side. So if you know the lengths of the two parallel lines and the perpendicular height h, you can use this formula to find out the area of a trapezium. So here you need to remember these two are the lengths of parallel sides. And what is h? Perpendicular height. For example, now we'll try to apply this formula so you can get different trapeziums. So here this is 2 centimeters, this is 5 centimeters and the perpendicular height is given 4 centimeters. What's the area of this trapezium? So how can we find out? We can find out using the formula half the sum of the parallel sides 2 plus 5 and perpendicular height is 4. So according to Bodmer's you have to do the brackets first. Half 2 plus 5 7 times 4. Now how can you simplify? You can divide by 2. 2 times 1, 2 times 2. 7 times 2 you get 14 square centimeters. Now we'll take another trapezium with different shape. This is also a trapezium, 4-sided figure and only 2 parallel sides are there. So here I'll take, this is the perpendicular height as well. It's given 4 centimeters, this is 7, this is 3. How can we find out the area of this trapezium? So you can use A is half times, what's the two lengths? 3 and 7. And what's the perpendicular height here? Perpendicular height is given like this because this is 90 degrees. So here you can substitute 4 there. So simplify this, half 7 plus 3 becomes 10. 4. And now you can simplify 2 get cancelled out with this 4 and you get 2 here. 10 times 2, 20. 20 square centimeters for the area of this trapezium. So remember when you get a trapezium shape, how you find out the area? Half times the sum of the two parallel sides times the height. Now we'll look at the last shape. So that's a circle. So you have done this before in grade 9. If you know the radius r, how can we find out the area of a circle? So area is equal to pi r square. So here you can memorize this formula and find out the area of a circle. And what is the pi value? Pi value we can take as 22/7, or sometimes they will give you the pi value as 3.14. So depend on the question, you can take either 22/7 or 3.14. Now we'll take an example. You have given a circle with 5 centimeter as the radius. Find the area of this circle. So area, straight away you can use the formula pi. Pi is, you can take either 22/7 or 3.14. I'll take 22/7. 5 times 5. So what we can do, we can't simplify here, so just multiply. 5 times 5 is 25. 25 times 22. So you get here 50. So you get 550. So 550 divide by 7. So you can write as a fraction or in decimals, just divide and write down. So 550 divided by 7, how much? 7 times 7, 49. 6 for 60, 8, 56 and 4 remaining. So either you can write 78, 4/7, or you can write as decimal as well. So you divide further and write down the decimal value. So here we'll take another example. If it's a circle with, this one is 14 centimeters. What is that? Diameter is given 14. So how can we find out the area? You need to know the radius. So what is radius here? Half of the diameter. So if 14 is the diameter, what's the radius? Divided by 2. So here area is equal to pi. Pi you can take 22/7 times. So what's the radius here? 7. 7 times 7. Now we see 7 get cancelled out. 22 times 7. 7 times 2, 14. 1 remaining. 7 times 2, 14 plus 1, 15. So you get 154 square centimeters. So what's the area of a circle? You can use pi r squared. Now we'll look at the review exercise in your textbook. So what are the shapes we did? We found out the area of a square, parallelogram, rectangle, triangle and a circle. Now we'll try to use these formulae in these questions. What's the first shape? That's a square. So what's the area of this square? We know the length is 6. Straight away 6 times 6. 6 times 6, 36. What's the unit? Square centimeters. So here, what's the area of this figure? Area is equal to, this is a rectangle, length into breadth. So length is 9, breadth is 4. So what's the area in this rectangle? 9 times 4, 36 square centimeters. What about this one? This is a triangle, right angle triangle. So how can we find out the area? Area is equal to half times base length times the perpendicular height. The perpendicular height is 4. Now try to simplify 6 and 4 in the numerator and 2 in the denominator. So you can cross it out, 2 with 1, 2 with this one, 2. 6 times 2, 12 square centimeters. So what's this shape? A circle with radius 7. So what's the area of this circle? Pi we can take 22 over 7. R is 7, R squared. So when you simplify this, 7 get cancelled out. So 22 times 7. 7 times 2, 14, 1 remaining. 7 times 2, 14 plus 1, 15. So 154 square centimeters. Now we'll look at the other shapes. So what is this one? This is an acute angle triangle. We know the base length and the perpendicular height. So straight away you can use the formula half times base length into perpendicular height. Now try to simplify this. 24 and 7 in the numerator and the denominator you get 2. Simplify 2 times 1 and 2 times 12. 12 times 7. Multiply 7 times 2. 14, 1 remaining. 7 times 1, 7 plus 1, 84. So what's the unit here? Square centimeters. What is this shape? A parallelogram. So the base length is given 12 and the perpendicular height is given 8. So how can we find out the area? Straight away, length into height. So 12 times 8. So what is 12 times 8? 8 times 2, 16, 1 remaining. 8 times 1, 8 plus 1, 96 square centimeters. What is this shape? This is a trapezium. Trapezium, two lengths are given, parallel lengths given 6 and 10, and the perpendicular height is given 6. So what's the area of this trapezium? Half times the sum of the two parallel lengths, 6 plus 10, into perpendicular height. First, simplify the brackets. 10 plus 6 is 16. Half times 16 times 6. You can simplify 2 with 1, 2 with 3, 3 times 16. So what is 3 times 16? 3 times 6, 18, 1 remaining. 3 times 1, 3 plus 1, 4. 48 square centimeters. Now we'll look at question number 2. In question number 2, it says the rectangle in figure C, that's this one, has been formed by joining together the trapezium and this triangle. Find the area of the trapezium in figure A. So we'll do the first part. How you find out the area of the trapezium? Here, to confuse you, they have given all lengths. So you need to identify what are the measurements that you are taking. Here you need only the parallel sides, so that means 5 and 8, and the perpendicular height. Perpendicular height is 4. So here you are multiplying this by 4. Try to simplify this. 5 plus 8 is 13 and 4. So when you divide, what happens? 2 times 1, 2 times 2. So 13 times 2, you get 26. This is square centimeter. So that's the area of the trapezium. So second part they ask, find the area of the triangle. So triangle, this is a right angle triangle. What's the formula? Half times base length is 3, perpendicular height is 4. So try to simplify this. 2 with 1, 2 with 2, 2 times 3, 6 square centimeters. And the third part, find the area of the rectangle in figure C in terms of the areas of figure A and figure B. We know when you add these two together, you get the rectangle. So what's the area of the rectangle? You need to add these two lengths. So 26 is the area of the trapezium, 6 is the area of the triangle. When you add these two together, you get 32 square centimeters as the area of the rectangle. Now we'll look at the third question. In the third question, it says the figure denotes a trapezium of area 33. So the whole thing is 33 that has been formed by joining two triangles together. Find the area of the triangle which is shaded. So here it's given the total trapezium area is 33 square centimeters. We can find out the area of this triangle because length and base length and the perpendicular height is given. So what's the area of the triangle? Area of triangle, you can find out half times base length into perpendicular height. So when you simplify, you get 3 times 7, 21 square centimeters. And you know the trapezium area is 33. So what's the shaded area? Shaded area is equal to, so the full thing subtract the area of the triangle. So what's the subtraction? You get 2 and 1. So 12 square centimeters for the shaded region. Now we'll look at fourth question. The figure denotes a parallelogram of area 120. So the full area is given 120. Its perimeter is 64. Determine the following based on the information that is given. First part, they want the length of the side CD and the length of the side BC. So we'll try to figure out that. Okay, so you have given the perpendicular height. That's 6. So here the area of this is 120. So if this is area 120 and we'll put this side is A or something, A. So how can you find out the area of a parallelogram? We know area of the parallelogram is A times 6. That's the height and the base length. But we know the area is 120. So we can substitute 120 for A. Simple A times 6. So how can you find out simple A? You need to divide this by 6. So 6 times 2, you get 20 centimeter for the base length. So after you get base length, that's actually the length of the side CD. So you can write CD length is 20 centimeters. Now we need to find out the length of the side BC. But according to this triangle, according to this parallelogram, we know A is 20 centimeters. And opposite sides are equal. This is also 20 centimeters. We need to find out BC length and AD length, same length there. So I'll put this one as X or something. This is also X. We know that the perimeter of this figure is 64. So that means the outer length of this parallelogram is 64. So I can write 20 plus 20 plus X is equal to 64. I can find out X by solving this equation. So I get 40 plus 2x is equal to 64. 2x equals 40. You need to take it to the other side. 64 minus 40, you get 24. So what is x there? X is you divide this by 2. So 24 divided by 2, you get 12 centimeters. So what is x there? X is basically the length BC. So you can write the length of BC is 12 centimeters. Now we'll look at the area of a sector. So here what is a sector? We did in lesson 1. When you get a circle and when you take a part of it, the shape bounded by 2 radii and the arc length we call a sector. Now we'll try to find out the area of a sector. So before that, we know if it's a circle, what's the area of a circle? So we know that area of a circle is pi r squared. So here we know what's the full angle around this point? 360 degrees. So here if it's 360 degrees, what's the area? It's pi r squared. Now what is 1 degree represent? 1 degree means pi r squared divided by 360. And if we want the sector area and the angle at the center, if it's theta, so theta is a Greek letter, it's the angle at the center. So how can we find out the area of that sector? If the angle at the center is theta, so that means pi r squared over 360 into theta. So I want to rearrange this and write down the area of this sector is, I'll write these two together, angle divided by 360 into pi r squared. So here if you know the angle at the center and the radius r, you can find out the area of the sector using this formula. So what's the formula? Angle divided by 360 into pi r squared. So we'll take an example. You have given a sector like this and angle is 30 degrees and the radius is 7 centimeters. So here radius is given 7 and the angle at the center 30. So we can apply the formula. So what's the area of the sector? Angle is 30 divided by 360 into pi. Pi is 22 over 7 into radius is 7 into 7. Now we'll try to simplify. We'll take another color. I can see 7 and 7 get cancelled out. This 0 get cancelled out and 3 with 1, 3 with 12. And again I can see 12 and 22 I can divide by 2. This is 6, this is 11. So what's the answer? You get 11 times 7, 77, divide by 6, and when you divide further you can write down as a mixed number 1, and for 17 that's 2, 6 times 2, 12, you get 5 remaining. So 12 and 5 over 6 square centimeters. Example 1 in your textbook related to the area of the sector. So this is a sector. Angle at the center is 45 and the radius is given 14 centimeters. So you are asked to find out the area of the sector. So how can we find out the area of the sector? So what's the formula? Angle divided by 360 into 2. What's the formula? Pi r squared. Pi you can take 22 over 7 into r squared. So 14 times 14. Now we'll try to simplify this. We can divide by 9. 9 times 5. 9 times 40. 5 times this one 8. Here this 7 and this 14 you get 2. And this 2 and this 8 you get 4. Again You can divide by 2. 2 times 2, 2 times 11. So again 14 and 2, you get 7. So 11 times 7, you get 77. What's the unit? Square centimeters. Now we'll look at example number 2. So here it's given the area of the sector is 17/1/9. Find the radius of the corresponding circle. So again, this area formula, you can use the area formula. Area is equal to angle given as 40 over 360 into pi r squared. Pi you can take 22 over 7. What's the r value? We don't know. We can put r squared, but we know the sector area is given as, what's the sector area? It's given as 17/1/9. So how can we simplify? First we can convert this to improper fraction. So what is 17 times 9? 6. 9 times 1, 9. 9 plus 6, 15. 153 plus 1, 154 over 9 is equal to, I can simplify this side. 0 get cancelled out. 4 with 1, 4 with 9. So here what you get? 22r squared over 9 times 7. Now how can we find out r squared? I can make r squared as the subject. So here I need to multiply this by this value. So here I am multiplying by 9 and 7, divide by 9 and 22. Now simplify. So 9 get cancelled out. You are getting 11 times 2, 11 times 1, 11, 44, it's 4. So 14 times 7. Here 2 times 1, 2 times 7. So 7 into 7 becomes 49. So what's the square root of 49 to get r? So r is equal to square root of 49. We know 7 is the square root of 49. So what's the radius value? Radius is equal to 7 centimeters. Now we'll look at exercise 6.1 in your textbook. So here all these are sectors. So you are asked to find out the area of the sector. So what's the first one? It's a semicircle. So what's the angle at the center? It's 180. In this shape, angle is 90. That's a quarter of a circle. Angle here is 60. What about the other one? That's a reflex angle. That's equal to 280. So now we can use the formula. What's the formula we can use to find out the area of a sector? Angle divided by 360 into pi r squared. Here r is not 14. What's r value? 14 is the diameter. So here we can plug 7 as the radius, not the 14. So 7 times 7. Now try to simplify. We know 180 times 2 is 360. And 1 7 get cancelled out. So here you get 44 times 7. So what is 44 times 7? 7 times 4, 28. 2 remaining. 7 times 4, 28 plus 2, 30. So 308 square centimeter for the area of the sector. In the second part, what's the area? You can use area formula. Angle. Angle is now 90. 90 over 360 into pi. Pi is 22 over 7 into r squared. R is here 14. 14 times 14. Now try to simplify. 90 and 360 you get 4. 7 with 14 you get 2 here. Now we can see 4 and 2 again. You can simplify 2 times 1, 2 times 2. Again 2 and 14 you get 7. So 22 multiplied by 7. 7 times 2 14, 1 remaining. 7 times 2 14 plus 1 15. So that's 154 square centimeters. Now look at the third one. What's the angle at the center? Angle at the center is 60 degrees and the radius is 21. So what's the area of the sector? Angle divided by 360 into pi. Pi is 22 over 7 into r squared. So 21 times 21. Now try to simplify this. 0 get cancelled out. 6 times 1, 6 times 6. And here 7 times 3. So what's the, again you can divide by 2. 2 times 3, 2 times 11. And this 3 get cancelled out with this 3. So you get 11 times 21. So what is 11 times 21? 11 times 1 is 11, 1 remaining. 11 times 2 is 22 plus 1, 23. So 231 square centimeters. Now we'll take the fourth one. So what's the area of the fourth one? Angle at the center is now 280. So angle divided by 360 into pi. Pi 22 over 7 into r squared. R is here 3 centimeters. So 3 times 3. Now try to simplify here. 0 get cancelled out. 6 times, no, you can divide by 2. 14 and 18. Again divide by 2. 7 and 9. Now can you see? This 3 becomes 9 and get cancelled out with this 9. This 7 and this 7 you can cross out. So what's the final answer? You get 22 square centimeters. Now we'll look at question number 2. It says the areas of the two sectors of circles given below are 77 and 462 respectively. Find the angle at the center of each sector. So here they want the angle now. And the area is given, first one 77 and the second one 462. So we'll try to use the formula. So what's the area formula? Area is equal to angle divided by 360 into pi. Pi you can take as 22 over 7 into r squared. Here 10.5, it's easy to take as a fraction. So what is 10.5? 10 and a half. And then when you convert to improper fractions, this is 2 times 10 plus 1, 21 over 2. I can write r as 21 over 2. Now, can you simplify? Here, I can see 7 with 1, 7 with 3. This 2 and this 22, you get 11. So what else? Here, this one divide by 3, you get 7. Divide by 3, you get 120. And what else? 3 times 1, 3 times 40 is 120. So you get 77 is equal to 11 into 7. In the numerator, you get 11 and 7 theta over, in the denominator you get 40 and 2. So make theta as the subject of the formula. So you get theta equals, that means you multiply 77 by 40 and 2 divide by 11 and 7. So we see 11 and 7 is 77. That one get cancelled out with this 77. So what's the angle here? 40 times 2 is 80 degrees as the angle at the center. Now we'll look at the second one. Area is given 462. So again apply the formula. 462 is equal to angle divided by 360 into pi. Pi is 22/7 into radius squared. So radius here is 21. Can you simplify now? Here 7 with 1, 7 with 3. This 3 with 360 you get 120. So here again divide by 3 you get 7, divide by 3 you get 40. What else we can do? We can simplify 22, divide by 2 you get 11, divide by 2 you get 20. So you get 462 is equal to angle into 11 and 7 in the numerator, and denominator you get 20. So how you make theta as the subject of the formula? Theta is equal to, you multiply this by 20 and divide by 11 and 7. So how can we simplify? We see 11 times 1, 11 times 4, 44, 2 remaining, 11 times 2, 22. So 7 times 6 is 42. So 20 times 6 you get, the angle is 120 degrees. Now we'll look at question number 3. In question number 3, the areas of the two sectors of the circles given below are 792 and 6 and 2/7 square centimeters respectively. For each sector, find the radius of the corresponding circle. Now, angle at the center given, you are asked to find out the radius. So, we'll put R as the radius and we'll apply the same formula. Now, we know area. Area 792 is equal to what? The angle divided by the 360. So, 280 divided by 360 into pi. Pi is 22/7. R we need to find out. I'll put R squared there. So, then try to simplify this. I can see 7 times 4, 28. This 0 get cancelled out. 4 with 36 you get 9. So what's remaining there? 792 is equal to 22r squared over 9. Now make r squared as the subject of the formula. So you get r squared is equal to 792 multiplied by 9 divided by 22. Divide this by 11, you get 2 here. Divide this by 11, 11 times 7, 77, 2 remaining. 11 times 2, 22. 72 divided by 2, you get 36. So here r squared is 36 and 9. So when you are taking the square root, you can take the square root of both these values. So here I can write square root of 36 and 9. We know square root of 36 is 6, square root of 9 is 3. So what's the answer? 6 times 3, 18 centimeter is the radius for this sector. What about this one? This is a fraction, mixed number. So you can convert this to improper fraction first. So when you convert, what you get? 6 times 7, 42. 42 plus 2, 44. So 44/7 is equal to, angle is 80 divided by 360 into pi. Pi you can take 22/7 into r squared. Now try to simplify. 0 get cancelled out. Divide by 2, you get 4 and 18. Again divide by 2, you get 2 and 9. Now rewrite this. You get 44 over 7 is equal to 2 times 22 r squared over 9 times 7. Now make r squared as the subject of the formula. R squared you get 44 multiplied by 9 and 7 divide by 2 and 22. Now simplify. 22 times 1, 22 times 2 is 44. 7 with this 7 get cancelled out. This 2 and this 2 get cancelled out, you get 9. What is square root of 9? So r is square root of 9. You get 3 centimeters for the radius of this sector. Now we'll look at compound figures. So far we discussed about separate figures, finding area of separate figures, rectangles, circles, sectors. Now compound figures. In this example, what are the two shapes you got? You got a square and a semicircle. So we'll try to find out the total area of the compound figure. So here what we can do? We can straight away find out the total area is the area of the square. So what is area of the square? Length times length. So 14 times 14 plus. This is a sector. Semicircle is a sector with angle at the center is 180. So we can write down straight away the formula. Angle divided by 360 into pi. Pi I can take 22 over 7 into r squared. Now what is r there? This 14 is the diameter of the circle. So divide by 2 you get 7. So 7 times 7. Now simplify this. So what is 14 times 14? 10 and 4. You get here 4 times 4 16. 1 remaining, 4 times 1 4. 4 plus 1 5. So when you add, you get 196. So what's this part? 180 times 2 is 360. 2 and this 21, you get 11. This 7 get cancelled out. So what's this side? 11 times 7, 77. So what's the area of the full diagram? So you get 6 plus 7, 13, 1 remaining, 10 plus 7, 17, 1 remaining, 273. What's the unit? Square centimeters. Now we'll look at example number 2. So this is a compound plane figure consisting of a rectangle and 2 sectors of a circle. Find its area. So you can add all these 3 areas together. So how can we find out the full area? Area of the rectangle. Length times breadth. 10 times 7. Plus. What is here? One area of a sector here. Can you see the same angle you got? That means the areas are equal. And the radius is 7. So you can find out area of one sector and multiply by 2. So I'll find out area of one sector is angle divided by 360 into pi. Pi is 22 over 7 into r squared. R is 7 times 7. I am multiplying this by 2 because there are 2 sectors. So what's the answer? You can simplify this. 7 with 7. This 0 with this 0, 3 into 1, 3, 3 times 12, 36. Now again I can divide this by 2, I get 6 here. Again divide by 2, I get 11 and 3. So here I get 10 times 7, 70 plus 11 over 3. So here I can write as a mixed number. 11 over 3 means 3 times 3, 9 and 2/3. So when you add 7 and 3, 73 and 2/3. So what's the unit here? Square centimeters. Now we'll look at third example. Third example, it says the shaded portion is obtained by cutting 1/4 of a circle from a rectangular lamina. Find the area of the shaded portion using the given data. So here you want to find out the area of the shaded part. So how can we find out the area of the shaded part? Area of the rectangle and subtract the area of the sector. So we'll try to find out the area of the shaded part. Area of the rectangle, 20 times 7, because length and breadth given 20 and 7, minus what is the area of the sector? So you can use the formula angle. What is the angle here? 90 degrees. So the angle is 90 divided by 360 into pi. Pi you can take as 22/7. What's the R value? Can you see in this part? This is the R value. That's 7. So 7 times 7. Now first we simplify this part. 90 times 4 is 360. This 7 and this 7 get cancelled out. So you get 4 times, again 22 and 4 divide by 2, 2 and 11. So you get 11 times 7, 77 divided by 2. So what is 20 times 7? You get 140 minus 77/2. So here you can convert this one to, what is 77/2 as a mixed number? You get 2 times 3, 6, 2 times 8, 16, 38.5. So 140 and 38.5 means 38.5. So 140 minus 38.5. So what you get here? 5, 9 minus 8 is 1, this is 0, 101.5. So here I can write this one as 101.5 or 101.5 centimeter square or squared centimeters for the shaded region. Now we'll look at exercise 6.2. In this question, you have given a compound figure and it says this is a square and 2 semicircles given. So the first part it says find the area of the square. So how can we find out the area of the square? You can multiply length into length. That's 14 times 14. So what is 14 times 14? That's 196. So you can write 196. I'll write here square centimeters. What's the second part? Find the radius of the semicircle portion. We know this length is 14. So that's the diameter of the circle. So what is the radius of the semicircle? You divide this by 2. So 14 divided by 2, you get 7 centimeters. Now we'll look at the third part. Find the total area of the 2 circular portion. So 2 semicircles, you get 1 full circle. So what's the area of 1 full circle? Pi r squared. So you can use pi r squared. Pi is 22/7. Radius we found, that's 7. Simplify this. 7, 7 get cancelled out. 22 times 7. 7 times 2, 14. 1 remaining. 7 times 2, 14 plus 1, 15 centimeter square. And the last part it says find the area of the compound plane figure. Now we know this whole compound figure consists of one full circle and a square. So what's the area of the full thing? We found area of the square, it's 196 plus. What's the area of full circle? 154. So when you add these two together, 6 plus 4, 10, 1 remaining, 10 plus 5, 15, 1 remaining. So 350 square centimeters. Now we'll look at question number 2. So in this one, the shaded portion in the figure was obtained by cutting out two semicircular parts from a rectangular piece of paper. Find the area of the rectangle and then find the total area of the two semicircle parts, and the third part, find the area of the shaded portion. Okay, so we'll do the first part. Find the area of the rectangle. So length is given 25, breadth is 7. So what's the area of a rectangle? 25 times 7. So what is 25 times 7? 7 times 5, 35. 3 remaining. 7 times 2, 14. Plus 3, 17. So 175 square centimeters is the area of the rectangle. Now they want what's the area of two semicircular parts. Semicircle and semicircle, you get full circle. So area of the circle is pi r squared. Pi is 22 over 7. What's r here? Diameter is 7. So what's the radius? 7 divided by 2. So pi r. R I can write 7 over 2. 7 over 2. Now try to simplify. 2 with this one, you get 11. 1, 7 get cancelled out. So 11 times 7 is 77 divided by 2. So you can write as a mixed number. 2 times 3, 6. 1 remaining. 2 times 8, 16. So 38.5 square centimeters. So find that area of the shaded portion. So shaded portion you are getting by subtracting the area of circle from area of rectangle. So you can find out area of the shaded part is area of the rectangle 175, area of the circle 38.5 as decimal. You subtract these two. When you subtract, you get 10 minus 5 is 5. This is 4. 14 minus 8 is 6. This is 6. 6 minus 3 is 3. So 136.5 square centimeters for the shaded portion. Now we'll look at third question. So in the third question it says you got a compound plane figure consisting of a parallelogram and a sector. Find the area of the parallelogram. So we can easily use the formula. What's the area of a parallelogram? Length into perpendicular height. We know length is 30. Perpendicular height is this one, 7. So you can multiply and find out the area of the parallelogram. So what is 30 times 7? 210. So what's the unit here? Square centimeters. So in the second part, find the area of the sector. So we need to know the angle at the center. And what is radius there? How can we find out the radius? Here, this length is 30. So this length also 30. So you can find this part by subtracting the total length 44 and this length 30. So 44 minus 30 you get 14. So 14 is the radius of the sector. So how can we find out the area of the sector? And also you need angle at the sector. We know this full angle is 180. So this is 30. So what is this angle? 180 minus 30, you get 150. 50 degrees. So what's the area of the sector? Angle 150 divided by 360 into pi. Pi is 22/7 and the radius we found, that's 14. Now try to simplify this. 7 with this you get 2. And this 0 get cancelled out. 3 times 5, 3 times 12. And 2 times 1, 2 times 6. Again divide by 2, 11 and 3. So you're getting, here there's an easy way of multiplying. So I'll write this one as 5 times 11 times 2 times 7. Instead of 14, I can write 2 times 7. Divide by 3. Now can you see 5 times 2 is 10. 11 times 7, 77. 77 times 10, you can write 770. Divide by 3. So what is 770 divided by 3? Divide by 3. 3 times 2, 6. For 17, 3 times 5, 15. You get 20. 3 times 6, 18 and 2 remaining. So 2/3 you are getting 256 2/3 square centimeters for the area of the sector. So the last part it says find the area of the compound figure. So compound figure is basically the parallelogram and the sector. So you can add these two areas. So area of the full part is 210 plus 256 2/3. So 2/3 we can separately take it, and when you add these two you get 6 and 6 and 4. So what's the total area? 466 2/3 square centimeters. Now we'll look at fourth question. So in this fourth question, you are getting a circular lamina of radius 28. That means the full radius of this one is 28 centimeters. The two sectors in the figure are to be cut out. Find the area of the remaining portion after the two sectors have been cut out. That means you need the other part. So how can we find out? We can find out the area of the full circle, areas of the two sectors, and then subtract to get the other portion. So here first thing we'll find out area of the circle. So what is the area of the circle? Pi r squared. Pi is 22/7, r is 28. You can write 28. So when you simplify, what you get? 7 times 4 and 28 times 4. You get 4 times 8, 32, 3 remaining, 4 times 2, 8, 8 plus 3, 11. So 112 multiplied by 22. 112 multiplied by 22, you multiply 20 and 2, multiply by 2 and you get 224 here. So when you add it, you get 2464. What's the unit? Square centimeters. And then we'll find out separately the areas for the sector. So area of two sectors we'll find together. When you take the first one, angle at the center is 30 and the radius is given 14. So you can straight away use 30/360 into pi, that's 22/7, into r is 14 times 14 plus, what's the area of the other sector? Angle is given 150 and the radius is given 14. So 14 times 14. So when you simplify this, you can see all these are common terms. So I can take 22 over 7, 14 times 14, and 360 common for both of these terms, and then I get 30 and 150. So what is 30 and 150? I get 180. So 22 times 14 over 7 times 360 times 180. So when you simplify, what you get? This times 2. 180 times 2 is 360. So 7 times 2 is 14. This 2 and this 2 get cancelled out. So you are getting 22 times 14. So what is 22 times 14? We'll multiply 20 and 2. 2 times 4, 8. 2 times 1, 2. And then when you add, you get 308. So what's the area? 308 square centimeters. That's the area of 2 sectors. Now we want to find out the remaining portion. When you cut those 2 sectors, what's the remaining portion? So what's the final part? So area of the remaining portion, you can find out area of the full circle is 2464, area of 2 sectors 308. You subtract these 2. So when you subtract, 14 minus 8 is 6, 5 remaining, and then 1 and 2. So what's the area? 2156 square centimeters. Now we'll look at the 5th question. In the 5th question, it says the following is a figure consisting of 2 sectors of circles. Show that the ratio of the area of the smaller sector to the larger one is 1 to 3. So here this is the smaller one and this one is the bigger one. So we'll first find the area of the smaller one. So angle at the center is now 45. So 45 over 360 into pi r squared. How can we find out r? We know this big one is 21. So this is also 21. How can you find out the radius of the smaller sector? We subtract. So r is equal to 21 minus 7. You get 14 centimeters. So pi value here 22 over 7. R is 14 and 14. That's the smaller one. So when you simplify, what you get? 9 times 5, 9 times 40. 5 times 1, 5 times 8. And here 7 and 14, you get 2. And 2 times this one is 4. Again, you can divide by 2. 2 times 11 and 2 times 2. Again, with this one 2, you get 7. So what's the area? 11 times 7, 77 square centimeters for the area of the smaller one. Now we'll find out the area of the bigger sector. So what's the angle now? Angle for the bigger one is 45 plus 15. So what is 45 plus 15? You get 60 degrees. So the angle for the bigger sector is 60 divided by 360. Pi is 22 over 7. What's the radius? Radius of the bigger one is 21. Now try to simplify this. 0, 0 get cancelled out. 6 with 36, you get 6. 7 with 21, you get 3. And here, divide by 2, you get 3 here, 11 here. And again 3 with this 3, you get cancel out. And what is the final answer? 11 times 21. So 11 times 1 is 11, 1 remaining. 11 times 2, 22 plus 1, 23. So 231 square centimeters. So now what's the ratio between smaller to bigger? Smaller one is 77, bigger one is 231. So when you multiply 77 by 3, what you get? 231. So 70, when you simplify, you get 1, 2, 3. So the ratio between the smaller sector to the bigger one is 1 to 3. Now we'll look at the sixth question. It's given based on the measurements given in the figure, show that the area of the unshaded region of the larger sector is 7 times the area of the shaded sector. So you need unshaded part and the shaded one. So to find out the unshaded part, you need to look at the quarter of a circle and the semicircle. So you have to subtract the two areas. So we'll first find the unshaded part. Unshaded area. How can you find? We'll take the quarter of a circle first. That's a sector. Angle is 90 over 360 into pi. Pi is 22 over 7. What's the radius there? 7 and 7 becomes 14. So 14 is the radius. And then we subtract the shaded semicircle. In the shaded semicircle, the diameter is 7. So what's the radius? 7 over 2. So what's the angle for a semicircle? 180 over 360 into pi. Pi is 22 over 7. The radius we can write 7 over 2. Now we'll try to simplify. 90 times 4, 360. This 7 and this 14, you get 2. This 2 and this 4, you can get 2. Again, you can divide this by 2, that's 7. What about this part? 180 and 360, you get 2. This 7 and this 7 get cancelled out. And this 2 and this 1, you get 11. So you get 11 times 7 divided by 2 times 2. So you get from the first part, you get 22 times 7. And from the second part, you get 11 times 7 is 77 over 4. So when you subtract, what you get? Here I can first multiply 7 times 2, 14, 1 remaining. You get 154 minus 77 over 4 as a decimal. So I can divide 4 times 1, 4, 3 remaining for 37, 4 times 9, 36. So I can write as, I need a decimal value, so I can divide again 4 times 2, 8, for 20 that's 5, 19.25. So here this is 19.25. So when you subtract these two together, 154, 19.25. So what's the answer? When you subtract, you get 0.75. Here 10, 14, 1 remaining, 2, and then you get 3, 134.75. That's the unshaded part. So that's square centimeters. Now what's the area of the shaded part? So we know the shaded part is this. So that means this part. So here I can write the shaded part. Shaded part we found 19.25. So what's the ratio now? ratio between these two, the smallest to bigger one, they are asking to show this is 7 times bigger. So we'll see when you multiply this by 7, what you get. We'll multiply and see. 7 times 5, 35, 3 remaining, 7 times 2, 14, 14 plus 3, 17, 1 remaining, 7 times 9, 63 plus 1, 64, 6 remaining, 7 times 1, 7, 7 plus 6, 13. So can you see when you multiply the smaller area by 7, you are getting this one. So that means the shaded part to the other part is 1 to 7 ratio. Now we'll look at the miscellaneous exercise. So in this one, it's given find the area of the shaded portion, this area. So here, what are the two shapes you are getting here? You get a quarter of a circle, that's a sector, and a triangle. When you subtract these two, you get the shaded area. So straight away you can write down the shaded area is equal to area of the sector. In that sector, radius is 7 and the angle is 90. So 90 over 360 into pi r squared. Pi is 22 over 7 into r into r. So we need to subtract the area of the triangle. So what is the area of the triangle? It's a right angle triangle. This is 7 and this is also 7. So base length and the height is also 7. So what's the area of the triangle? Half times base into height. So here when you are simplifying, you see 7 get cancelled out. 90 times 4, 360. Divide by 2, you get 11 and you get 77 over 2 minus. Here you get 49 over 2. So when you subtract 77 and 49, what you get? 8 and 2. So 28 over 2, that's equal to 14 square centimeters. So that's the shaded area. When you look at this part, so you're asked to find the shaded region. So you can easily find out by taking the bigger one minus the smaller area. So here I can straight away write down the shaded region. This is about area. Area of shaded region is equal to bigger sector. What's the radius? 7 and 7. Radius is 14. What's the angle? 60. So I can write 60 over 360 into pi is 22 over 7. What's the radius? 14. 14 times 14. And you have to subtract the smaller sector. So what's the area of the smallest sector? 60 over 360 into pi 22 over 7. And what's the area? What's the radius? Radius is 7. So 7 times 7. So when you simplify, you get 60 times 6. 7 with 14, you get 2. 2 times 3, it gets cancelled out. And here, what else? You get 22 and 14 and 3 here. What about this part? 60 times 6. And here 1, 7 get cancelled out. So you are getting 22 and also you can divide by 2 and write 3 and 11. So you get 11 times 7, 77 over 3. So when you are subtracting, here what I can do, I can take 11 times 2. Here I can write, instead of 22, 11 times 2. And here I can write 11 times 7. 11 over 3 is common. Take it out. So what's remaining? You get 2 times 14, 28 minus 7. So what is 28 minus 7? You get 21. Now I can see 3 and 21, you get 7. 11 times 7, you get 77 square centimeters for the shaded region. Now we'll look at the third part. So you are asked to find the shaded part. So the shaded part is the area of these three sectors, and also this is equal to this one. So that means find the area of one sector and multiply by 2. So here I can write area of the shaded region is equal to, what's the area of the bigger one? Angle is 60. Pi is 22 over 7. Radius for the bigger one is 7. So you can write 7 times 7. And what about the smaller one? Angle is 30. Pi is 22 over 7. The radius is 3.5. I can write as 7 over 2. And I can multiply this by 2. Why? There are two sectors. So when you simplify, what you get? 60 with 360, you get 6. This 1, 7 get cancelled out. When you divide by 2, you get 11 here. So the first part you get 77 over 3. What about the other part? 30 times this, you get 12. Divide by 2, you get 6 here. Another, this one divide by 2, you get 11. So that's all. And 7 also get cancelled out. So what is the other part? You get 11 times 7 is 77. Divide by 12. Now, you can convert to the same denominator. Here 3, when you multiply by 4, you get 4 times 77 over 12, and this is 77 over 12. So, I see this is 77 over 12 is common. When you take it out, this is 4 plus 1. So 4 plus 1 is 5. So what's the answer? 77 over 12 times 5. So multiply by 5. 5 times 7, 35. 3 remaining. 5 times 7, 35 plus 3, 38. 38, divide this one, divide by 12. So 385 divide by 12. 12 times 3, 36. You get 25. 12 times 2, 24. 1 remaining. So here we can write this is as 32 and 1 over 12 centimeter square. We'll look at question number 2 now. It says find the area of the shaded region. The curved line in the figure is the arc of a semicircle. So this is the arc of the semicircle. So when you look at the diagram carefully, we need to find out the shaded region. How can we find out? We don't need all these shapes. So when you look at this diagram, can you see if you take this quarter of a circle and then subtract the triangle, you get the shaded region. So here, when you take the quarter of a circle, what is the radius? So this whole length, the diameter is 14. So we know that this is 7. And also this is the radius. So this is also 7. So easily you can find out area. So the shaded region is area of shaded region is equal to area of quarter of a circle subtract the area of the triangle. So how we find out the area of quarter of a circle? We know angle is 90, pi is 22/7 and the radius is 7. And how we can find out the area of a triangle? This is a right angle triangle. Length and height is 7. Half times base times the perpendicular height. So when you do that, you get the area of the shaded part. So 7 get cancelled out. 90 times 4, 360. 2 times 2, 2 times 11. So you get 77/2 and this side 49/2. When you subtract these two, you get the shaded part. So 9, 8 is 17, you get 5 and 2. So 28 divided by 2, you get 14 square centimeters for the shaded part. Now we'll look at question number 3. It says the figure denotes the two semicircles show that the ratio of the unshaded region to the shaded region is 5:7. So when you look at carefully, so this is 60, this is 60. What is this angle? This is also 60 because the total angle is 180. So we can write this is 60. And here these two parts are equal. So you can first find the area of the smaller one and areas of these two, that becomes the shaded part. Unshaded part, how can we find? Take the full semicircle, subtract the shaded part, you get the unshaded part. So we'll first find the shaded area. So shaded area is when you take this one, the full sector minus the smaller one. So smaller one we can find out first. So what's the radius there? So the radius is, it's given A. So this is also A. So what's the radius of the shaded part? This big one is 2A. So we can straight away find out the area of this part. So I'm trying to find out this part. It's 60 divided by 360 into pi 22/7 into radius is 2A into 2A and subtract the smaller area. What's the smaller area? 60/360 into radius is A times A. So that's, when you do that, that's this part. So you get two parts like that. So you multiply this by 2 and then you have to add this area as well. So what is that area? So that area is 60 divided by 360 into pi r squared. R is again, this one is A times A. So when you simplify, you get the shaded part. So how can we simplify this one? So there's an easy way to do that. Can you see 60, 360 all common and pi is all common. I'll take that one out. And then the other part I'll simplify separately. I get 2a times 2a, 4a squared, and then multiply by 2, you get 8a squared, minus a and a squared, multiply by 2, 2a squared, then plus, I took this part out, then you get a times a squared. So when you simplify, what you get? Here 60 times 6 is 360. So 2 times 1 here, 11, 2 times 3. So 11 over 21. What's inside? 8a squared minus 2a squared, you get 6a squared, plus a squared, you get 7a squared. When you simplify, 7 with this, you get 3. So the answer is 11a squared over 3. That's the shaded area. So what's the unshaded area? So I can find out the unshaded area by subtracting the shaded part. So what's the full area of the semicircle? Angle is 180 over 360 into pi r squared. So what is r here? 2a. So 2a times 2a minus the shaded part. So we found shaded part is 11 over 3a squared. Now again, I'll simplify this. 180 times this is 2. 2 times this one is 11. And I'm getting 2 times 2, 4. 4 times 11, 44 over 7 a squared minus 11 over 3 a squared. So when I simplify this one, I can see 11 a squared is common. I can take it out. So what's remaining? 4 over 7 minus 1/3. Now I can convert to the same denominator and simplify. So what's the answer I'm getting? 11a squared. So what's the common denominator, lowest common multiple? That's 21. So when I simplify this one, I need to multiply this by 3. 3 times 4, 12. And subtract by multiplying this by 7. Because you need to get the same denominator. So 7 times 1, 7. So when you simplify, what you get? 11a squared over 21. 12 minus 7 is 5. So what's the answer there? You get 55a squared over 21. Now we found out the unshaded area and the shaded area. So we'll find out the ratio in between those two. So we need to find out first the unshaded region. Unshaded region is what? Unshaded part is 55 over 21 a squared. And what's the shaded region? Shaded region is 11 a squared over 3. Now we need to simplify. A squared get cancelled out. A squared get cancelled out. And here when you divide both sides by 11, you get 11 times 1, 11 times 5. When you multiply this by 3, you get 3 here and this is 7. So when you cross multiply, what's the ratio? You are getting 5 to 7 times 1, you get 5 to 7. Now we'll take question number 5. In question number 5, it's given a sketch of area in front of commemorative plaque is given in the figure. Grass has been grown in 3 portions within the semicircle which are in the shape of sectors of circles. So this is the grass area. White sand has been spread in the other regions. The radius of each sector within the semicircle is 84 centimeters. So this one is given 84 centimeters. And the first part, it says what is the radius of the semicircle in centimeters. So here it's given 2.1 meter for the diameter. So diameter is given 2.1 meter. How can we convert to centimeters? You multiply this by 100. 2.1 multiplied by 100 means you multiply it by 100 and put a decimal place. So 210, 2100, put a decimal place, you get 210. So diameter is 210 centimeters. So what's the radius? Half of it. So 210 divided by 2, you get 105 centimeters for the semicircle, the radius of the semicircle. So second part, they ask find the area of the semicircular part in square centimeters. So what's the area of the semicircular part? We know this is a sector with angle at the center is 180 and the radius is 105. So what's the area of the semicircle? Angle 180 divided by 360 into pi, 22/7. Radius is 105. 105 times 105. So what's the answer? 180 times 2. 2 times 11 is 22. 7 times 1, 7, 35, that's 5. And here you need to multiply 11 times 15 and 105. So we'll first find 11 times 105. 11 times 5 is 55. 11 times 1 is 11. Then multiply this by 15. 10 and 5. You multiply by 1 first and then multiply by 5. 5 times 5, 25. 5 times 5, 25 plus 2, 27. 5 times 1 is 5 plus 2, 7. 5 into 1 is 5. So when you add these two together, you get 17,325. So that's the total area of the semicircular part, that's in square centimeters. Now we'll look at the third part of that. So in the third part it says find the area of one of the sectors with angle at the center equals to 30. So they are asked to find out this part. We know that from the first part it says 84 is the radius. So this is 84. So how can we find out the area of one sector? Area of one sector is angle is 30, pi is 22/7 and the radius is 84. So how can we simplify this? 0 get cancelled out, divide by 3, you get 12. And here when you divide this by 7, you get 12. 12 times 7, 84. And here 12, this 12 and this 12 get cancelled out. So you need 84 times 22. So 84 times 22 multiplied by 20 and 2, you get 1848. What's the unit? Square centimeter. So that's area of one sector. So the fourth part they ask, what's the? Find the angle at the center of the large sector if its area is 1848 square centimeters more than the sum of the area of the other two sectors. Now here they are asking to find out this angle. What's the condition? It says the area of the large sector is this one more than 1848 square centimeters, more than the sum of the areas of the other two sectors. We found area of one sector. So what's the area of one sector? This. So when you multiply by 2, you get areas of two sectors. So what is areas of two sectors? You have to multiply this by 2. 2 times 1848. So what's the answer? 2 times 8, 16, 1 remaining. 2 times 4, 8, plus 1, 9. 2 times 8, 16, 1 remaining. 2 times 1, 2, 2 plus 1, 3. So that's the area of these two sectors. So here it says the center of the large sector, if its area is 1848 square centimeters, more than the sum of the areas of the other two. Now what's the area of the big sector? 1848 more than this. So you can straight away write down what's the area of the bigger sector. 3696 plus 1848. When you add these two together, 8 plus 6, 14. 14, 1 remaining, 9, 6, 15, 1 remaining, 5. 5544. So that's the area of the big circle, big sector. Now we can use the formula again for the big area. So here what's the area of the big sector? You can find out angle over 360 into pi 22/7 into radius. What's the radius there? So it's given 84. We know that's equal to 55. It's area 5544, 5544. You can plug the area there and you can find out the angle. How can we simplify this? Here, can you see 7 with this? You can write down 12. So then we'll rewrite and make theta as the subject of the formula. So what is theta there? Theta is equal to, you cross multiply this, that means 5544 multiplied by the denominator values and divide by the numerator values, 22, 12 and 84. So how can we simplify? First we'll divide by 12, 12 times 1, 12 times 3, so you get 30 here. Divide this by 11, 11 times 2, 11 times 5 and 11 times 4. So 504. I can divide again this with, divide by 2, 2 times 504, divide 504 by 2, you get 2 for 10, this is 5, 252. So when you divide this by 2 again, what you get? I'll write here, you are now getting 252, 30 and 84. I want to divide this by 2 again. 2 times 4, 2 times 2. So 2 times 1, 2 times 2, 4. For 12, that's 6. So I can see when you multiply 42 times 3, you get 126. So 42 times 3, 126. So you are getting the angle as 90 degrees. So the angle for the bigger sector is 90 degrees. So here we covered all examples and exercises in this unit. So memorize the area of all circle, square, trapezium, sectors and parallelogram, everything. You have to memorize the areas and try to apply this formulae in real life applications.